Hey, welcome to my channel. Today we're diving into one of Stephen Hawking's most mind-bending ideas, the multiverse. Get ready, because we're about to explore how Hawking believed countless universes could exist alongside our own, shaping reality in ways we can barely imagine. For centuries, humans have looked up at the night sky and wondered if we are alone. But as science progressed, we discovered that the universe is unimaginably large. Not hundreds, not thousands, but trillions of galaxies stretch out across the cosmic landscape. The concept of the multiverse suggests that what we call the universe may be one bubble in a vast cosmic ocean, one region among countless others, each potentially governed by its own laws of physics. The idea is simple, yet its implications are breathtaking. If there are many universes, each one might contain different forms of matter, different constants of nature, and different evolutions of time and space. Some would expand forever. Some might collapse quickly. Some might never form stars. And a few, perhaps only a few, might allow for the emergence of life. The multiverse is not simply a fantasy. It emerges naturally from several areas of physics. One of these areas is inflation theory, the idea that in the earliest moments after the Big Bang, space expanded at an exponential rate. Imagine a balloon inflating, but instead of growing smoothly, it forms small bubbles across its surface. Each bubble inflates into its own separate universe. They are disconnected. They cannot interact, and yet they each contain their own version of space and time. In this picture, our universe is simply one bubble among many. Nothing particularly special, just one cosmic region where the conditions happen to be right for galaxies, stars, planets, and eventually intelligent beings capable of asking questions about the nature of existence. Another path to the multiverse comes from string theory. According to string theory, the fundamental particles in nature are not points, but tiny vibrating strings. And these strings require additional dimensions of space, not 3, but sometimes 10 or even 11. Depending on how these extra dimensions twist, fold, or compactify, you get different physical laws. In one universe, gravity might be stronger. In another, electromagnetism might be weaker. In yet another, chemistry might unfold in ways impossible for life as we know it. This scenario gives rise to a landscape of possible universes, each corresponding to a different configuration of extra dimensions. Think of it as a vast library of cosmologies, each with a different story. Ours is only one volume on the shelf. A third source of the multiverse is quantum mechanics itself. In the quantum world, particles do not have fixed positions or states. Instead, they exist in multiple states at once, a phenomenon called superposition. One interpretation of this, known as the many worlds interpretation, suggests that every quantum event spawns a branching of reality. In one branch, an electron moves left. In another, it moves right. In one branch, you turn left on the street. In another, you turn right. In this view, the universe constantly splits into countless versions of itself. This interpretation is controversial. Some physicists accept it enthusiastically. Others reject it. But it demonstrates a simple truth. The idea of multiple universes is not an invention. It is a natural possibility within the mathematics of nature. But the most profound question is this. If a multiverse exists, what does that mean for us? If there are many universes, then the fact that ours allows for the existence of life becomes less mysterious. Life did not appear because our universe was designed for it. Instead, life appeared because out of countless universes, a few had the right conditions. And we happened to be in one of them. In a sense, the universe did not adapt to us. We adapted to the universe. This line of thinking relates to what scientists call the anthropic principle. It does not claim that we are special, but rather that our existence selects the type of universe we observe. Much like finding yourself on a planet with oxygen is not surprising, because you could not exist on one without it. Of course, the multiverse raises deep philosophical questions. If there are other universes, can we ever see them? Most likely, no. The cosmic speed limit set by the speed of light prevents us from observing anything beyond our own bubble. Those regions are forever outside our horizon. Their light will never reach us. In a sense, they are real, but unreachable. Some argue that if something cannot be observed, it cannot be considered science. But I disagree. Science is not limited to what we can see. It is about what we can predict. If a theory makes accurate predictions about our universe, and that theory implies the existence of others, then we must take that implication seriously. Consider the hydrogen atom. Early physicists could not see electrons. They could not detect their orbitals. But the theory predicted them, and the predictions matched reality. Only later did technology catch up and confirm the theory. In the same way, the multiverse might be a theoretical prediction waiting for future confirmation. One possibility is gravitational fingerprints. If another universe collided with ours early in cosmic history, it might leave a circular imprint in the cosmic microwave background, the afterglow of the Big Bang. Some scientists have searched for such patterns. The results are unclear, but intriguing. Even if we never detect another universe, considering the multiverse changes how we perceive existence. It reminds us that our universe, for all its beauty, might not be the only way nature can be. It suggests that the cosmos is not a single stage, but an infinite theater with an endless variety of performances. The multiverse also teaches humility. For much of history, humans believed Earth was the center of creation. Then we learned that Earth is one planet among many. Then that the sun is one star among billions. Then that our galaxy is one island among trillions. Now the multiverse proposes an even more humbling possibility, that our entire universe might be one tiny region of an even grander reality. But alongside humility, the multiverse also inspires wonder. In some distant bubble universe, physics might permit forms of life unimaginable to us. In another, stars might form differently. In another, the arrow of time might run in reverse. In yet another, the laws of mathematics themselves might not hold as we know them. Thinking about the multiverse is like standing before an ocean. You cannot see all of it. You cannot explore all of it. But knowing it is there changes everything. In the end, the question is not whether the multiverse exists. The question is whether the idea helps us understand our own universe better. Does it help us explain why physical constants have the values they do? Does it shed light on the nature of time and space? Does it guide us toward deeper theories of quantum gravity? In these ways, the multiverse is not a distraction. It is a path forward. And perhaps someday, with new physics, new mathematics, and new technology, the veil between universes might thin. Not enough for us to cross it, but enough for us to understand it. Until then, we continue to explore. We question. We calculate. We imagine. Because that is what humans do. And it is through imagination guided by reason that we uncover the true shape of reality. The multiverse may be vast, mysterious, and unreachable. But so once was the shape of the earth, the nature of atoms, and the structure of the cosmos itself. Every great scientific idea begins as something unimaginable. And then, through curiosity and courage, it becomes knowledge.